Hello everyone, today my topic is minimization of DFA. Minimization of DFA means for a particular language there are multiple types of DFAs. C2 and DFA-N. For this, if we take set of 6 states, and for this there are 8 states. In this we can have a less number of states than these two, like 5 states. Then we call this the minimal DFA. We can minimize a DFA by using two methods, or equivalence DFA and Myhill Neon. Today I am discussing about the equivalence DFA. Here equivalence DFA means there will be two states P and Q called equivalence if transition of P, W belongs to final state. Here P means states and W defines the string, implies transition of Q, W implies final. Here Q means states and W is same as strings. Here we had three conditions, that is P, a state P implies to final with the string W, and Q state with string W goes to final, then these two are equivalent. And second, if P state with W string goes to final and Q state with W string goes to non-final, this here it is non-equivalent. And third, if P state with W string goes to non-final and Q state with W string goes to non-final, this is equivalent. These are the three conditions for the equivalence DFA. Okay, now let's discuss an example. Here I have given a question, length of each string should be even. When I given a question to you, normally all will draw a DFA like Q0. First we'll write the strings which occur in this DFA, epsilon, AA, AB, A, and to so on. Now we'll draw a DFA for this. Here we'll start with state Q0 with a final state and with state A, B to Q1 Q2 A, B. Right? 90% of people draw the DFA like this. Here we'll check that the strings we have taken satisfy this DFA or not. Let's take epsilon. Yeah, it's correct. Here it is the final state, so this is correct. And A, it is also final state, so it is correct. Now we can minimize this DFA with two states. Now let's start the minimization of a DFA. Minimization of DFA. The first step here, we should draw a transition table. For this DFA. In transition table, first we should write the states Q0, Q1 and Q2 with string A and B. Now let's check. Q0 with string A goes to Q1. Let's write here. And Q0 with string B goes to Q1. And Q1 with string A goes to Q2. And Q1 with string B goes to Q2. Q2 with string A goes to Q1. And Q2 with string B goes to Q1. Next, after this, we should write a zero equivalent for this transition. In zero equivalent, we'll write the final and non-final states in different sets. Like here, Q0 and Q2 are final and Q1 is non-final. So we'll write Q1 in one set and Q0, Q2 in another set. Next, we should find the one equivalent. In one equivalent, we should not, there is no difference in Q1, so we will write Q1 as it is. We should check the Q0 and Q1 with strings A and B goes to same set or not. So we'll check. Q0 with string A goes to Q1 and Q2 with string A goes to Q1. This belongs to the same set. And we check with string B also. B. Q0 with string B goes to Q1 and same as Q2 goes to Q1. So here also we will get same set element. So we can't divide this Q1 and Q0 and Q2 into different sets. So here we will get Q0 and Q2 in same set as it is. Here 0 equivalent and 1 equivalent was same. So this is the final states that occur in a minimal DFA. So we should now change the transition table according to this set of states. Here Q0, Q2 we should combine. Like wherever you had Q0 you should write a Q2 and wherever it is Q2 you should write a Q0. Yes. Now we can draw the DFA for this. Like there are only two states here, Q1 and Q0, Q2. Here I will draw the minimization of minimal DFA for this transition. Now we will write the minimal DFA according to this transition table. Here we will have two states, Q0, Q2 and Q1. So Q0, Q2 is the first final state and with string A it goes to Q1 and with string B it goes to Q1 and then Q1 with string A goes to Q0 and Q2. So this is the final minimal DFA for this DFA. Now I am explaining an example too. Here this is a DFA. We should minimize this DFA. Here this Q0 state with input A going to Q1 and Q0 state with input B going to Q0. So this is the loop. Here Q1 with input A going to Q2 state and Q1 with input A going to Q3 state and Q3 with input B going to Q2 state. So here there is a condition, one condition that we should check that all states are reachable from the initial state. Set of states reachable from initial state. Here there are 4 states: Q0, Q1, Q2 and Q3. Here we should check that from Q0 we can reach to Q1 or not. Q0 with input A goes to Q1. So it is correct. We can't remove Q1 or Q0 from this DFA. So we can check for Q2. We can reach Q2 from Q0. We'll check that Q0 with input A goes to Q1 and Q1 with input A goes to Q2. So we can't remove Q2 also. Now we'll check for Q3. Q0 with input A goes to Q1 and Q1 with input A. Here there is no input to A or B to reach Q3. Now we'll check from Q2. A, Q2, from Q2 input A or B. Q2 state with input B, it goes to Q2 only, not Q3, and there is no input to A from Q2. So there is no possibility that we can reach to Q3 from Q1 or Q2 or Q0. So we should remove this Q3 state from this initial DFA. Now we will write a transition table for the initial DFA. There are states Q0, Q1, Q2, Q3 with inputs A and B. Q0 with input A goes to Q1 and Q0 with input B goes to Q0 and Q1 with input A goes to Q2 and Q1 with input B goes to Q1 and Q2 with input A goes to Q1 and Q2 with input B goes to Q2, Q3 with input A goes to Q1, Q3 with input B goes to Q2. So here we have removed Q3 state, so we do not have this Q3 state in our transition table also. So there are only 3 states, Q0, Q1 and Q2. We should write the DFA, minimal DFA for this according to this transition table. So will be Q0, I'll write here. Q0. Here the final states are Q1 and Q2. Q0 with input A goes to Q1. Q0 with input A goes to Q1 and Q0 with input B goes to Q0. So it is a self loop. And Q1 with input A goes to Q2. Here Q1 is the final state and Q2 is also the final state. And Q1 with input B goes to Q1. So this is the self loop. And Q2 with input A goes to Q1. We should reverse it. And Q2 with input B goes to Q2. It is also the self loop. So for this DFA, this is the minimal DFA. Here we have removed the Q3 state from this DFA. So initially there are 4 states, and for this minimal DFA there are only 3 states. So these are the conditions for the minimization of DFA. Thank you very much.